Hey kiddos, today we're going to be discussing parallel lines and perpendicular lines. Okay, so parallel lines and perpendicular lines. All right, so just a few things to remind you guys about lines. Okay, we should recall that we can find slopes of our lines. We have positive slopes, we have negative slopes, we have zero slopes, and we have undefined or no slopes. Okay, slope basically just means that we're looking at a change in y divided by a change in x. Okay, so here's our slope formula as well. Another way when we're graphing to find slopes is looking at the rise over the run. Okay, this is slope intercept form. All right, y equals mx plus b, where the letter m represents your slope and where the b represents your y-intercept. Okay, remember, parallel lines are lines that have the same slope, so therefore their slopes are going to be identical. Intersecting lines are simply just two lines that intersect. So if I draw an example of that, it would look something like this. Okay. So nothing really special about intersecting lines. They just intersect at some point. But then more special, I don't even know if that's right, perpendicular lines, which are simply two lines that do intersect, but when they do intersect, they cross at 90 degrees, or aka they create right angles at their intersection when they cross. Okay, so that's what makes perpendicular lines special. All right, so we're going back to algebra here because this is what finding slopes are about. So in order to find a slope, you can always do that by picking 2 points that are on that particular line. Okay, and it can be any 2 points, and you want to make sure we're going to do this by using rise over run. So notice here it says slope A, so that means we're looking at line A, which is the blue line here. So if I look at a point, notice they already have a point given to me here, 8, 2, that point, and let's say I'm going to use this center point here, this 6, 4, as a point that I'm going to. I'm going to rise 2 units. So I rose 2 units. Okay, and then I go to the left 2 units. If I go to the left 2 units, that would be negative. So 2 divided by negative 2 would reduce to -1. Notice that slope is going downhill, which is another key way to remember that that slope should be a negative slope. Okay, so the first slope was -1. Now let's look at our line B. B is the color green. Okay, beautiful green. And we're going to use 4, 0 as the point that we're going to start at. So here we go. Let's see how many we have to rise. Remember, you always have to rise before you run. Okay, so you have to rise. So we're going to go up 1, 2, 3, 4 units. So if I go up 4 units, that's positive. And then I'm going to go to the right, which is positive, and I'm going to go to the right 1, 2 units to get to that 6, 4. So we have 4 over 2, and that reduces to positive 2. So the slope for line B is 2. All right, now let's look at the next one, which is C. Where is line C? Oh, it is pretty purple. Purple, so we're looking at this purple line here. And let's start at this point, 0, 4. 0, 4. Well, I don't have to rise. I don't have to go up or down to get to 6, 4. So my rise is 0 over, but I do have to go to the right. 1, 2, 3, 4, 5, 6. 6 units. 0 divided by 6 when I reduce it. Oh, right, 6. That's positive. 0 divided by 6, if I reduce that, is going to be, what do you know? 0. So there's a mathematical reasoning of why a horizontal line has a 0 slope and forever and always will have a 0 slope. And the last line, D, in pretty red. So the line in red, let us begin at 6, 0. Now I can rise to get to 6, 4, and I'm going to go up. That's positive 1, 2, 3, 4 units. So I went up 4 units. And sadly, I'm already at 6, 4, so I don't have to run anywhere. And if you do 4 divided by 0, you get what we like to call an error. You can't do it, okay? So in other words, when that happens, our answer is undefined, or you can also say no slope. But please make sure that you understand both words mean the same thing. So always vertical lines that go up or down, will always contain no slope or undefined slopes. All right, finding slopes of lines. So notice here, instead of having a pretty graph, we have 2 points, and we're going to solve for the slope. So we're going to use the formula. And notice I've already identified x1, y1, x2, y2, first point, second point. And all I have to do is plug in our values. So y2 is negative 2 minus y1, which is 4, divided by x2, 5, minus x1, negative 7. All right, if I simplify this, negative 2 minus 4, negative 6, over, I do notice that these double negatives turn into positives. So I get 5 plus 7. It's a grand total of 12. And I believe we can reduce negative 6 over 12 to a negative 1/2. So the slope then for this line that will contain these 2 points is negative 1/2. So I want you guys to work out this problem on your own. Again, first point, second point, here's the slope formula. Make sure you just plug in your values to get your answer. All right, are these lines parallel, perpendicular, or neither? So notice when we're trying to determine whether lines are parallel, perpendicular, or neither, the only thing you care about is the slope. Okay, notice these are in slope-intercept form. Well, I should say most of them are in slope-intercept form. If a linear equation is given to you and it's not in slope-intercept form, then the very first thing that you have to do is put it in slope-intercept form. So for the first equation in A, y equals 1/2 x plus 1, I know the slope-intercept form is y equals mx plus b, where m is in reference to the slope. So I know that in this first equation, the slope is 1/2. So we're going to work out the second equation to see if we get to solve for y so we can put it in slope-intercept form. So positive 6x, I'm going to subtract 6x to both sides. That cancels out. Bring down what's in my box. So 3y equals negative 6x plus 12. Put a plus in front of 12 because it was positive. And my last step here is going to be divide everything by 3. That reduces to 1y equals negative 6 divided by 3 is negative 2x plus 4. So the slope for this equation is a grand total of negative 2. Now, hopefully it's obvious that these two lines are not going to be parallel. So the next thing to see is, do they have a perpendicular relationship? Remember, to be perpendicular, you have to have 2 things. You have to be the opposite and reciprocal. So that means it has to be the flip. So if I start off with 1/2 and I make 1/2 the opposite, it would become negative because it's positive here. And if I flip 1 over 2 over, I get 2 over 1. And negative 2 over 1 is the same thing as negative 2, which is what I have here. So these two have a perpendicular relationship. All right, so for this next one, I actually want you guys to attempt it on your own as well. Notice the first equation, it's already in slope-intercept form, and you should already be able to establish what the slope is, okay? The second one, though, you do need to get y by itself, so you have one step to do, And then you should be able to tell me whether they're parallel, perpendicular, or neither. All right, using a ruler, graph the line through the given point with the given slope. So again, guys, this is really Algebra 1 work, all right? -1/4 is our slope, and I always like to break stuff down, rise over run. If I'm rising and I have a -1, that means I'm going to go down. 4 is my run, and it's positive, means I'm going to the right. Notice I already have my point plotted at -3, 2, and I'm going to use my slope here going down 1 and to the right, 1, 2, 3, 4 to plot more points. Down 1 to the right, 1, 2, 3, 4. And I can always move the opposite direction, which would be to go up 1 and to the left, 1, 2, 3, 4. So once I have all those points, now obviously, since you guys have a ruler that you're using, this line should be like super straight. So forgive me for not having it super straight. All right, and you guys go ahead and do B on your own. I kind of already helped you out here, 7/3. So 7 is your rise, so that means you're going to be going up 7, and your run is going to go, because it's positive, to the right. Now, obviously, if you haven't already noticed from this point that you plotted, 4, 5, you can't really go up 7 because you'd be totally off the graph. So you have to use, or you have to go in the opposite direction. So instead of going up 7, you'd actually really go down 7 and to the left 3. Okay, so keep that in mind when you're plotting this graph. And of course, here's just a few more for you guys to do on your own. Notice, hopefully you guys recall, these should be really simple. The slope is the zero slope, so hopefully you recall what a zero slope looks like. Next one is an undefined slope, and hopefully you recall what an undefined line looks like. All right, next example. A bike path is being constructed parallel, keyword, parallel, to a highway through point -1,4. The equation of the line representing the highway is y equals 3x minus 2. Find the equation of the line representing the new road. Graph both lines. So we need to see if we have this line graphed already, which is y equals 3x minus 2. So notice that's probably what we want to make sure we do first. If that is the case, a few things that you may want to identify is that the slope is 3, your y-intercept is -2. Always start by beginning with graphing your y-intercept, okay? So that is going to be found on the y-axis, okay? That's y, that's x. It'll be found on your y-axis at -2, okay? First thing you do. Then from there, you can use your slope by doing rise over run, which is to go up 1, 2, 3 to the right 1. So this is basically what your line should look like, okay? So that is our highway, okay? So this is the highway. And what they're doing is they're constructing a bike path. So we're looking for the bike path now. And key thing they gave us is that it's parallel. So if the bike path is parallel to it, then we should hopefully recall that that means that the slopes will have to be the same. So therefore, the slope would be 3, because it has to be the same as the highway slope, and the highway slope was 3. So notice they also said that the bike path was going to be going through the point -1, 4. So I went ahead and already plotted -1, 4. So my bike path is going to go through this point and using a slope of 3. Well, in order to write out our equation here, y equals mx plus b, it'd be really nice if we went ahead and finished this graph and we looked at where this bike path, okay, crosses our y-axis, because that would then give us the answer of what our y-intercept is going to be. So using our slope, which we already know is 3, and if we're doing rise over run, we're going up 3 units and to the right 1. All right, now I can't continue going up 3, right 1, because I'll be off the graph. So we're actually going to go in the opposite direction, which would be go down 3, left 1, so that I can continue drawing this picture. That's as far as I can go. Obviously, make sure you guys are using a handy dandy ruler so your line looks 10 times better than mine. And so that's what the bike path, okay, would look like, parallel to the highway. Now, in order to write this equation, y equals, we already know m is 3x, our y-intercept. So where did our bike path cross the y-axis? Hopefully we see that it's right here at this point, and that is 1, 2, 3, 4, 5, 6, 7. So our y-intercept is 7. So y equals 3x plus 7. So that is the equation of our line. All right, so next example, we have a hiking path is being constructed perpendicular. So here you guys want to make sure that you recall what perpendicular means. It means that these two lines, their slopes are going to be opposite of each other and reciprocal of each other. Okay, so a hiking path is being constructed perpendicular to the river through point 3, -4. Okay, so I went ahead and plotted that point. The equation of the line representing the river is y equals -5/2x plus 3. Okay, find the equation of the line representing the bike path. Graph both lines. I'm gonna let you guys do the most of the graphing on your own. So let's start off with the original slope, okay? Because that's very important for us to know what's the original slope that we're working with, and you'll find that in the equation of the line that represents the river, which is -5/2. Now, we have to find a slope that is going to be perpendicular to that, so we want to make it the opposite. So if it's a negative, then we'll be making it positive. And we want to take the reciprocal of that, so we're going to flip that fraction to 2/5. So our perpendicular slope is going to be 2/5. Now, before we can find the y-intercept, I'm going to see if I can find it easily by actually graphing it. So if you notice, I already have the point 3, -4 plotted, and I'm going to use our slope that we just discovered, which was the 2, 5. So I'm going to go up 2 and to the right 5. 1, 2, 3, 4. Notice I can't really go to the right 5 because I'll be off the graph here. So let's see if we go the opposite direction, down 2 into the left 5. All right, now if I draw and use your ruler, because your line should look 10 times better than mine, I'll do that. Notice it looks like I'm crossing at exactly 1, 2, 3, 4, 5, but I bet you if you're looking at yours with your perfect ruler, that's probably not really the case. So let's just say that's not really on -5. So how would we go about then figure out what the y-intercept is? Well, pretty simple. We're going to use our slope-intercept form. We're going to use the point that they've given us, and we're going to use the slope that we just discovered we want to use. So all I'm going to do is plug it in. So y is -4 equals m, our slope that we want that's perpendicular is the 2/5, times x, which is 3, plus b. And b is what we don't know. We're trying to discover what that is. So mathematically, let's go ahead and simplify this. I get -4 equals 2/5 times 3 is 6/5 plus b. Now, technically, I'm solving for b, so I would normally subtract 6/5 to both sides. And if I get -4 minus 6/5, I have to change that -4 into a fraction with a denominator of 5. So I would make that -20/5 minus 6/5, and that would result in an answer of -26/5, which means that is actually what the value of b is. Now, I don't know about you guys. If I said, hey, graph -26/5, I'd be kind of confused as far as where exactly that would go. So it's always a little bit easier if we change that into a decimal, which you get -5 5.2. So notice I was correct in saying that that's not exactly at -5 for the y-intercept, okay? It's actually a little bit lower at -5.2. So the equation of this line then, that's going to be perpendicular to the river, is y equals 2/5 x minus 5.2. All right, just to re-emphasize parallel symbol, okay, parallel symbol in a picture looks like this. And the symbol is usually just two straight lines side by side, two L's, lowercase l's kind of thing. Perpendicular symbol is the upside down T. You'll notice two lines to be perpendicular to each other typically when you have lines or when you have a right angle being demonstrated. Kind of gives it away that they're perpendicular. All right, so the question here is, based on this picture, are the following statements about the figure true or false? All right, so let's analyze. RS, line RS, okay, is parallel to line QD, okay? QT. I love those two together. QT. So is RS parallel to QT? Hopefully you can see that that is true. All right, 2. AB, line AB. Here it is. Line AB is perpendicular, upside down T, okay, perpendicular to RS. AB perpendicular to RS. That's kind of a giveaway right there that this statement is true. All right, 3. RS, here you are, RS, and CD. Are they parallel? Hopefully you say that those are two lines that are intersecting, so that's false. They're just intersecting. Nothing special about them, they just intersect. 4. Looking at CD, all right, this line here, and thinking it's perpendicular to RS. Now, I know perpendicular lines are two lines that do intersect, but remember, they're a lot more special than that. They create 90 degrees at their intersection, and I don't see that happening here. So that's false. They're just intersecting. CD, here we go, CD again, is parallel to QT. QD and CD. Are they parallel? No, I see clearly that they do intersect here, so that would be false. And the last one, AB, is perpendicular to QT. AB perpendicular QT. What do you think? It would be true. Now you might be wondering, well, hey, there's no marks here or anything like proving that. Well, recall that if these are in fact perpendicular here, and these two lines we've stated are parallel to each other, then therefore these two lines would have to also be perpendicular. Okay, so keep that in mind.